This is a problem set that's supposed to help you understand the ideas behind the exit ticket, if those were a little bit new to you and a little bit difficult. So I'm going to work my way through it. What I would recommend is that you follow along with the video, but you stop before I do each solution. You try it on your own. You could listen to what I do and then stop the video again and don't look at my code. See if you can reproduce the same thinking that I did without looking at mine. Okay, so it's 3 problems. I don't think it's going to take more than about 20 minutes. So the first problem is going to help us just think about the for loop and the while loop separately. And we're going to generate a number sequence using the same rule from the exit ticket. It's called the hailstone sequence. I didn't tell you that. So the rule is, given a starting number, to get the next number, you look at the last number in your sequence, and if it's even, you divide it by 2 to get the next number, and if it's odd, you multiply by 3 and add 1. So let's always use 27 as our starting number just to start out. So we'll use a for loop to generate 20 terms in the sequence, storing each term in an array list. And very soon we're going to stop using an array list. But let's do it. So I know if I'm going to need an array list, I'll need to create it. I'm not allowed to create an array list of int for reasons that I'll explain later. Array lists have to use objects, and the object version of int is called integer. So I'll just call it list, and I'll run the constructor. Constructors always have this keyword new. Okay, so I said I'll use a for loop. It said generate 20 terms in the sequence, so it sounds like I'll want it to loop 20 times. Let's think about this. So I want 27 to be my starting number. So I guess let's add 27 as the first number in my list. And now what I want to do, sometimes it helps to write out a plan just in regular English. So my plan is I want to get the last number in the list, because that's the most recent one I generated. And then if it's even, I'll want to divide by 2. Otherwise, it has to be odd. So then I'll multiply by 3 and add 1. And then I'll be at the bottom of the loop, and I'll do it all over again. But when I do it all over again, I'm going to do it based on the last number in the list. So it's really important that I remember when I generate the next number, I also want to add that next number to the end of the list, because otherwise when I repeat, I won't have made the list any longer. Okay, so let's implement this plan. I'll get the last number in the list and store it in a variable called last. I'll call it last num. The way that you can get the last element, well, the way you get any element out of an array list is get and then an index number or a location number. So that would get the first thing in the list. That would get the thing at location 1 or location 2 or location 3. When you're looping over a list, we frequently use I here because I is already visiting locations starting with the first one going up. But in this case, I don't want to visit all the locations starting with 0 and going up. Like right now, my list only has one thing in it. So I just want to get the last thing in the list. So let me just pause it for a second. Let's just think this through. Let's pretend list had 4 numbers like this. The location of 27 is index 0. The location of 4 is index 1. The location of 1 is index 2, and so on. So if I wanted to get the last thing in the list, I need to get 3 in this imaginary example. But the problem is I can't just give it a number because I don't know how long the list is. So I need to ask the list how long it is. I can do that by saying list.size, and list.size is going to tell me the total number of things in the list. So list.size is going to be 4. And if I wanted to, I could break that out into its own variable. So I could say length equals list.size. That's a number, 4. And then I could say, I could use that length as a location number. Oops, length. But it wouldn't make any sense to say, give me the thing at location 4, because you can see that there is no location 4. That's off the end of the list. So you could do this. You could say like last location is the length of the list minus 1. Because if the list is length 4, the last location number is 3. If the list had been length 3, so here I only have 3 numbers, the last location is 2. So I can say, give me the size of the list and subtract 1 to give me that last location number. I'll store it into last location. And now I can say, give me the thing that's at that last location. Typically, once you are familiar with this, you wouldn't actually have this variable. You can just put this part directly into get. This is a little bit harder to look at unless you're familiar with the pattern, though. And so there's absolutely nothing at all wrong with having a variable that tells yourself what you're doing here. So I'll just leave it like that. Okay, so all of that was just to let me get the most recent thing in the list, the last thing in the list, and it's called last num. So now in my plan, I say if that's even, I want to divide it by 2, otherwise add 3 and multiply by 3 and add 1. So I think I want a new variable called next for next num, or I'll call it next num. And I'll just set it to 0 for the moment because I'm going to overwrite it in a second. So if last num is even, and remember the way to test for that is to look at the remainder when you divide it by 2. So if the remainder when you divide it by 2 is 0, that must mean it is evenly divisible by 2. So in that case, the next number is going to be my last number just divided by 2. Otherwise, so if it's not even, then I know it has to be odd. And so next number is going to be the last number times 3 plus 1. All right. And so last thing is I got to add the next number to the end of the list. So my list is called list. So I'll say list.add next num. And there we go. Let's go ahead and display the entire list here inside the loop. So that way we can watch it build up one step at a time. So I'm going to go ahead and run this and we'll see what it looks like. All right, so 27, and then because that's odd, it's going to generate the 82 as the next number. And then the next loop, I generate the 41, and then the next loop, I generate 124. So you can see every single loop has a new print statement, and I'm making the list one longer. Let's make one quick change here. I don't actually need to define next number because I can just take my previous number, my last number, and divide it by 2, and then save it right back inside last num. So this would be saying like, take the last number, divide it by 2, and just make that be the new last number. And then I don't need so many variables. Oops, last num. And then because there is no next num anymore, then last num is what I want to add to the list. So that's a thing that you could think about. If you want to, you can pause the video and kind of think about why that should make sense. All right, let's go to the next part of the problem. So in part B, it says modify your code so that you don't use any array list. You just have a single variable called last, or I guess for us it's called last num. Change the problem. That stores the last term, and we use that to generate the next term. So we've almost done that already. It's a little bit silly here where we're taking last num and we're adding it to the end of the list. And then when we repeat, we get the thing that's at the end of the list. But the thing that's at the end of the list is just last num because we just added it there. So let's remove the list entirely. I'll create last num here. And to start with, the last num is just our starting num because before we've made the list, we only have one number. And so the last num is the same as the first num. Okay, so now we don't need this stuff anymore. So last number is 27, and now we're saying if that number is even, we'll replace it with itself divided by 2. Otherwise, we'll replace it with itself times 3 plus 1. And so now we don't need to add anything to the end of the list because we replaced last number with the one that it's supposed to become next. So we're not saving all of the numbers in the list. Instead, we're just taking the one number and turning it into what it would become next in the sequence. So we don't have a sequence anymore. We're generating it, but we're not keeping track of all of the numbers. And that's okay. So just to make sure we're doing this right, let's print out what the number is here at the top of the loop. So we'll print out last num and then a space, and we can run it. And remember these numbers. We've got 27, 82, 41, 124. We'll run it, and we'll see that it's going to do the same thing here. So we've got 27, 82, 41, 124. So it's generating the same numbers. It's just generating them one per loop, and we're not storing them. So in the next part of the problem, let's modify the code so that we use a while loop that will keep going until we generate a 1. So instead of a for loop that will loop 20 times, I'm going to use a while loop. And the while loop will keep going as long as this test is true. So it might be tempting to say, like, keep going until last num equals 1. But do you see how I said the word until? I said keep going until last num equals 1. That's the way that you think about it sometimes. But a while loop, you don't give it the condition here for when you want it to stop. And last num equaling 1 is when I want it to stop. Instead, you give it the opposite. You give it think about it like an if statement. You could say, what's an if statement for should I do another repeat? So like if I don't want to stop, that means I want to do another repeat. And so I guess I'd want to do another repeat as long as the last number isn't equal to 1. So this is like logically tricky, and as we do more problems, I'll give you more tools for thinking about this. But just be aware that you might naturally want to think about an if statement for when do you stop, but while loops, you think about what needs to be true for me to keep repeating. So as long as my last number isn't 1, I'll print what it is, I'll replace it with the next number in the sequence, and then I'll come back to the top and do it all over again. And so now we can run it, and you can see that, whoa, it's very long. So it generates lots and lots and lots of numbers until eventually it gets to 2. And you might be thinking, well, why did it not display 1? And the answer is because we display last num as 2. Then we go here, since 2 is even, we divide it by 2, and it becomes 1. And then we test up here, and now last num equals 1. And so we exit without ever having done this print statement again. So you could have a print statement on the outside of the loop to print the last term if you want. Okay, last part of the problem. Let's add a counter that counts how many times the loop repeats. So it would be a mistake to put the counter here, because this is inside what's getting repeated. And each time I generate a new number, it's going to set the count back to 0. So it wouldn't really be counting. So let's put the count out there. And then I can do count plus plus. Some people were putting the counter in the if and the else, which is okay. But notice that if you put it in both places, you're really saying sort of no matter what, you should add to the count. If the number's even, add to the count. Otherwise, if the number's odd, add to the count. So here I'm just saying each time the loop repeats, I'm making a new number, so I want to add to the count. So here, let's print out the total length, and that will be the count. Let's run it and see what it looks like. 111 terms in that sequence. Cool. All right, let's look at part 2. The rest of this is going to go a little bit faster. Okay, so in part 2, we're going to use a similar pattern. Here's some code with just a couple of blanks, and we should fill in the blanks so the code will generate random numbers until it gets the same number twice in a row. And we're going to do that only by filling in the blanks. So to think about this, you want to think about what's going to happen line by line as we generate, and then think about what do we want to be true about the problem. So here, we're not repeating yet. We're just going to generate a random number, which we're saving as last, which I assume means the last number that we've generated. And then we've got this number previous, which is like the number before the last. And I set it to -1 because we haven't looped yet, and so there is no previous number. So I set it to sort of a neutral value that I know can't possibly match the last random number. Okay, so I want you to think about the while statement. Remember, what needs to be true if we want to keep repeating. And so then we have just 2 statements in here. Each time the while loop repeats, we want to generate a new random number. But we want to check if the last 2 things that we generated are really the same. And so before we replace the last number with a new random number, we have to save it into the previous. Because as soon as we make a new random number, then what used to be the last random number isn't the last one anymore. because we will have replaced it with a new one. And so now it's going to be the previous one. So go ahead and pause the video and try and fill it out and maybe put in a print statement that you can use to check to make sure this makes sense. All right, here we go. So I'm going to say while last is not equal to previous. So while the last two things I generated are not equal to each other, I want to take my last number and save it inside previous. And remember, a single equals sign means take the value on the right, store it inside the variable on the left. So I'm saving the last value as my previous value. And now I'm safe to replace the last value with a new random number. So I'm just going to copy this part up here. All right, so let's go ahead and put a print statement so that we can test. So I'm just going to print the last two numbers I generated. So we'll print previous, and then a space, and then last. And before we start, I'm just going to print so last, and then a space, or sorry, previous, and then a space, and then last. So actually, let's do it like a couple of spaces. Okay, here we go. Let's run it, and we'll see what it looks like. So here it says previous is 8, and last is 6. So in other words, I've generated two numbers now. I generated 8 and then 6. And then the next loop, 6 isn't going to be, well, let's do it again. It's confusing that this was 8 because it makes it seem like it's the same thing. Okay, so here I've got 7 and 3. So then in the next loop, my last number 3 becomes my second to last number, my previous number, because I've generated a new last number, which is 10. And then in my next loop, the last number 10 gets assigned to previous, and I generate a new number, which is 9. And I keep going that way until eventually I generate two that are the same, and then I stop. So you can run this a couple of times yourself, see how it makes sense. Oh, here I got it right away. No repetitions necessary. Here it had to do a bunch of times. It says add a counter that we can use to count how many times this happened. So let's add a count. It'll start at, I'm going to start it at 1 because we've already generated one number here before we even start. And then here I'm going to increment the counter. And then at the end, I'll say count total numbers. Here we go. So 7 total numbers. And let's see if that's true. I generated an 8, and then a 5, and then a 10, and then another 8, and then a 3, and then a 1, and then a 1. So 1, 2, 3, 4, 5, 6, 7. And that's how many total. Great. So it seems to have worked. Okay, so last problem. It's a lot shorter. Here is code that is a solution to problem number 1. So I start with first number being 27. I save that as also the last number, and then I'm going to have a count for how many terms. And as long as the last number isn't 1, I want to keep generating new numbers. So I'll check if the last number is even, and if it is, I'll replace it with itself divided by 2. Otherwise, I'll replace it with itself times 3 plus 1, and I'll add to the count because I have one more number, and then I'll check it again. Is it 1 now? And if it's not, I'll change it and then check it again to see if it's become 1, and eventually I print out the length. So if we wanted to do this for different starting numbers, obviously we could change this. Now we're going to do it for a starting number of 4 or a starting number of 6. What we really want to do is make a method, because a method is going to give a name for this whole process. It's going to let us encapsulate this whole process as a single command. So I'm going to cut all this, and I'm going to type in what I wish were true. I think in my problem I said we should call it getSequenceLength. And we'll give it a starting number like 27. All right, so let's make the method. And I'm going to call this starting num. And I'll paste my code. All right, so I don't want to have first num being 6 anymore, because now the starting number is going to be the input to my method. So if I said 27 up here, the 27 is going to get saved inside starting num. If I had something else, it would be something else. So I'm going to delete that. And I'm actually going to rename this thing from starting num to first num, just so that I can reuse the variable name I already have. So whatever number was the one that we wanted to know about, that gets assigned to first num. then everything else is the same. I save first num into last, and then I generate all the things, except at the end, I don't really want to print the length. I want to return the length so that it can get saved inside this variable, so then I can do other calculations with it. Like maybe I could see if it's the biggest thing I've seen so far, if I'm generating lots of sequences. So instead of printing the count, I'm going to return the count. So now we have this nice method that I can use as its own command. And now I can just collapse it and kind of forget how it works. And I can, use it to generate as many different things as I want. So let's have a for loop that goes from 2 up to 1,000. And then I'll plop this inside the loop. And so now instead of saying, so now this is like looping almost 1,000 times. But instead of getting the sequence length for a starting number of 27, I'm going to get it for a starting number of I. So each time we loop, I is going to be a different number, and I'm going to generate a sequence with a different starting value. And then I could print out, starting with I, its length, and then length. And so now I can just see how long all of them are. So like pretty powerful. With 855, there's a length of 55 before we get to 1. All right, let's do the last piece of this. Let's modify it now. Oh, so let's add a counter to count, and then we'll find the longest. So count equals 0. Let's not print this anymore. Instead, I'll say if the length is larger than 100, that's when I want to add to the counter. And then at the end, I can print out how many. Let's run that. So there were 248 different sequences that were longer than 100. Okay, let's figure out what the longest one was. So I'll do longest length so far is going to be 0 because at the beginning I haven't seen it yet. Let's add another if statement here. I'll say if the length of the one I just made is bigger than the longest one I've seen so far, then I want to remember it as the longest one I've seen so far. So I'll take the current length and I'll save it into this longest so far variable. So then the next time I come through and I have a new sequence with a new length, I can say, is the new length even longer than that one that I'd seen? The problem is at the end, it would be really helpful for me not just to say like what the length of the longest sequence was. So let's actually do that. Here, I'm going to delete the count part. I don't want to count anymore. Okay, so we'll run it. And it's going to give us one number. So 179 is the length of the sequence that was the longest. But I don't just want to know the length. I want to know what was the starting value that made such a long sequence. So I'm going to call it start value to save. And I'm going to set it to 0 because we don't know what the longest sequence is yet. But each time I find a sequence that might be the longest, it's longer than the longest one I've seen so far, I'm not only going to save that length, but I'm going to save the starting value that I used. So remember, I was the starting value that I used to make the sequence. So when I find a long sequence, I'm going to take I and I'm going to save that value. So then later on, I can say start value to save is longest with length and then longest length so far. So without further ado, 871 is the number that generates the longest sequence, at least in the first 1,000. Okay, I hope this was helpful.